2021 October, November, paper 11. So let's take a look at question number 1. It is given that the three informations over here, alpha plus beta plus gamma equal to 3, alpha square plus beta square plus gamma square is equal to 5, alpha cube plus beta cube plus gamma cube is equal to 6. And actually, they are the alpha, beta, gamma are the roots of the cubic equations over here. Find the values of B, C, and D. So over here, we know that the B is actually equals to the negative alpha plus beta plus gamma. So the B will be a negative 3. Then for the C, we need to use this result is equal to 5. So this is actually the formula will be alpha plus beta plus gamma square minus the 2C is equal to 5. So you will get this as the negative 3 square. Oh, no, not negative 3. It's a 3 square minus a 2C is equal to 5. Then you will get this one as a C is equals to the 2. So we found the C. Then as for the D, to find the D, we need alpha multiply beta plus gamma. However, we will need to declare that we let Sn equal to the alpha power n plus beta power n plus gamma power n. Okay, then we will be having S cube plus the bx square. B will be a negative 3 and the C is a 2 we have just found, plus the D is equal to 0. So we can actually make this become S cube S3 minus the 3S2 plus the 2S1 plus the D S0. So we already have S3. S3 is a 6. S2 is a 5 and S1 is a 3. So we have 6 minus the 5, 3 times 5 plus the 2 times 3 plus the 3D is equal to 0. So just use the calculator. You get the 15 minus a 6 minus a 6 divided by 3. That will be a 1. Done. So this will be the answer for the questions number 1. So now we move on to the question number 2. Have 2A, use a standard result from the list of the formula booklet MF19 to find the series over here in terms of n and fully factorizing your answer. So what we need to do is we just expand them. You will get r cubed plus the 3r squared plus the 2r. So we will break them into 3 parts. This will be the r cubed. This will be the r squared. This will be the r. R equal to 1 until n. R equal to 1 until n. So formula booklet will give you n square n plus 1 square over 4. This one will give you 3n, n plus 1, 2n plus 1 over 6. And this will give you n plus 1 over 2. So you can see that they have a common factor of, we have a common factor of n plus 1, n and n plus 1. We factorize the 4 out. So here we'll get n plus 1. Here we'll get 2 of n plus 1. 2n plus 1. Then this one, it will be a 1. A 4. Okay, so this is what you're supposed to get. Expand, simplify, then you will get the answer. So this one will give you n squared plus the 4n, 5n plus the 6. Okay. Then we can still factorize it because they want a fully factorized form. So we have a n plus 2 and n plus 3. Done. So this will be the answer for the number 2A. Okay, so now we move on to the question number 2B. Now we are looking for the reciprocal of it. 1 over r plus 1, r plus 2. We need to find the partial fractions, decompose this fraction first. So we will make it become a over r plus b over the r plus 1 and c over the r plus 2. So you will get this as the r plus 1, r plus 2. Okay, then use the substitution method when the r is equals to the 0. So you will get 1 is equal to 2a. Then your a is a half. Then when the r is a negative 1, so you will get 1 is equals to the negative b. That means the b is a negative 1. And when the r is equal to the negative 2, so you will get 1 is equal to the 2c. That will give you c is equal to half. Okay. So therefore, the decompositions of these fractions, it will be 1 over 2r minus the 1 over the r plus 1 plus the 1 over the 2r plus 2. Okay, so this is what we will be having. Now we want to find the sum, or the sum of the n term starting from r equal to 1. So we just use the partial fraction that we have found earlier, replace them inside. Just substitute the value, you can get this one as a 1 over 2 minus 1 over 2 plus 1 over 6, and plus the 1 over 4 minus 1 over 3, and plus the 1 over 8. Then 1 over 6 minus the 1 over 4 plus 1 over 10. And this pattern will continue. You can see that these 3 of them can be cancelled off. And to make it a better understanding, I write one more row. It will be 1 over 8 minus the 1 over 5 plus the 12. So you can see that these 2 also can cancel off, and the pattern will continue in such a way until, let me show the last 2 rows, because I have these 3 value remain. Then the last 2 pair, there will be last 3 terms, and the 3 terms will be remain as well. So I will write the last term will be 1 over 2n minus the 1 over the n plus 1 plus the 1 over the 2 of n plus 2. And this will be 1 over the 2n minus 1 minus the 1 over n plus the, let me try to squeeze in everything here first. Okay, so it will look like this. Then perhaps let me just have one more terms over here. then you can see that this also can be cancelled off. So the pattern will behave in such a way that at the end, the remaining answer will be this, is equal to the half minus half plus 1 over 4 plus the half 1 over 2 n plus 1 minus a 1 over the n plus 1 plus the 1 over 2 of n plus 2. Simplify it, you get 1 over 4 minus this plus this. So there's no need for you to simplify them become a single fraction because the question didn't mention require you to do so. So we can just leave our answer for number 2b like this. Done. Then I move on to C. We want to deduce that the sum of the series over here when the n is approaching to infinity. So what you need to do, just need to write this sum to infinity. Is actually equals to the limit of the n approach to infinity from the expressions that we have found in our part 2. And when the n approach to infinity, this will become 1 over 4 because this will become 0. This will become 0 as well. So the answer will be 1 over 4. Done for the number 2. Okay, now we take a look at question number 3, the sequence of real numbers. We are given A1, A2, A3, such that the A1 is a 1 and the rest of them will behave in such a way AN plus 1 is equals to the AN plus 1 over AN power 3. Proved by mathematical induction that the ln AN is greater than or equals to 3 power n minus 1 ln 2 for all for all integers that is n greater or equal to 2. And there's a hint over here. We may assume that this result is true for all the x is greater than 0. Typing error over here. Okay, so now let's take a look at how to prove it. So we need to start from n equal to 2. So when n is a 2, that means I need to show that ln A2 is greater or equal to this. Okay, I need to show this when n is equal to 2. But I need to find A2 first. So A2 is actually equals to the A1 plus 1 over A1 cube from this given in the questions. So it will be 1 plus 1 over 1 cube is equal to the 2 cube. Okay. So ln A2 is equals to the ln 3 is equal to the 3 ln 2 and is equals to the 3 power 2 minus 1 ln 2. Okay. So it's true for n equal to 2. Okay, because we need to show that this is true when n is a 2. Assume true for n equal to k, which means that the ln ak is greater than or equals to the 3 power k minus 1 ln 2. Okay. Then when your n become k plus 1, so as usual, we need to find, we need to have this ln ak plus 1 is equal to the ln of ak plus 1 over ak power 3. Okay, as given in the informations over here. We just change our n become k. So it's a k plus 1. Okay. Then we can, because in the questions, they mentioned that this, we can assume this result directly. So from the hint, we know that this is actually bigger than the ln AK power 3. So it will be equals to the 3 ln AK. And since the ln AK already greater than this, so because of ln AK greater than 3 power k minus 1 ln 2, so therefore ln AK plus 1 is actually greater than 3 multiply this. Okay. So over here, maybe we should write down. This is greater. Then just expand them. You will get ln AK plus 1 greater than 3 power k plus 1 minus 1 ln 2. So it's true for n equal to k plus 1. So therefore, by the BMI, we will say that the ln an is greater than or equal to 3 power n minus 1 ln 2 for all integers n greater or equal to 2. Integers n greater or equal to 2. Done. So this will be the answer for the number 3A, 3 part A. So now we want to go for 3 part B. They wanted to show that this is true for n greater or equals to 3. So the questions over here, we need to apply the result in part A. So result in part A, we have a ln an plus 1 minus a ln an. Is actually ln of an plus 1 over an power 3. Okay, so this is what we have. We can bring the 3 goes in front. You know that an plus 1 over an is actually bigger than the an. Okay, so which means that the ln an plus 1 over an is actually greater than the ln an because of this reason. So we just say that this is bigger than 3 ln an minus a ln an. Okay, so these are erased. And if you combine them, you will get this is equal to the 2 ln an. Okay, so your an, ln an, just now we know that we know this ln an, change the k become n is greater or equals to 3 power n minus 1 on 2. This one just mentioned that it's from part A result. So you will get this one as therefore ln an plus 1 minus a ln an is actually greater than 2 power of, we can bring the 2 goes up. So you will get this one as the 3 power n minus 1 ln 2 square. Ln 2 square is actually a 4. Okay, ln 2 square is actually a 4. So we just run like this. Done. This will be the answer for the number 3b. And moving on, we have question number 4. The type of each transformation and make clear the order in which they are applied. So right here, we need to know that for the 2 geometrical transformations over here, this is the first transformations, followed by the second transformations over here. So the first transformation is actually one-way stretch. Parallel to the x-axis. With scale factor 3. Okay, so because of the value here is 3, so the scale factor is 3. Then followed by the second transformations over here. This one obviously is rotations. Anti-clockwise. Center at about O, about the origin. Through angle theta. Okay, so this is the answer for the part A. Then move on. Part B. Find the values of theta for which that the data is between 0 to pi. The transformation represented by M has exactly one variant line through the origin. Okay, and giving your answer in terms of pi. So we need to multiply the M over here from 2 matrices to become 1. So this is the cos theta, sine theta, negative sine theta, and cos theta. Okay. So if you multiply them, then you will get this as a 3 cos theta. Then this is a negative sine theta. This is a 3 sine theta. And this is a cos theta. Okay. So in order to find the invariant line, so we let our invariant line is y equal to mx. Then your image will be the y prime equal to the mx prime. Okay. So to find invariant line, just write x mx equal to the x prime mx prime. So this is the 3 cos theta negative sine theta. This is the 3 sine theta and cos theta. Okay, so if you multiply them, then you can see that actually we can make it become 3 cos theta minus the sine m sine theta. We can factorize the x out, and it's equal to x. Then for the second component over here, it will be 3 sine theta plus the m cos theta x is equal to the mx prime. So this will be the equation 1. This will be the equation 2. Take the equation 1 divided by equation 2, then you will get 3 cos theta minus the m sine theta divided by the 3 sine theta plus m cos theta equal to the 1 over m. So just do the cross multiplications, you get 3m cos theta minus the m square sine theta. is equal to the 3 sine theta plus m cos theta. So you get m squared sine theta minus the 2m cos theta plus the 3 sine theta. So this you can see that the m is we treat the m as a unknown or the variable. Then we can say that this is a quadratic equations. In order for these quadratic equations, in order for the m to have only one value, only have one solutions for the m, that means the discriminant must be a 0. So we just have the discriminant equal to 0. That means the b squared minus a 4ac must equal to 0. So you will get this will be 4 cos square theta minus 12 sine square theta equal to 0. So we can actually make it become tangent square theta is equals to 1 over 3. Then the tangent theta will equal to the positive 1 over 3, and tangent theta will be equal to the negative 1 over 3. So for this answer, your theta will be 60 degrees, or we want to write the answer in terms of radian. So we give the pi over 6. Then another answer for this one, it will be 150 degrees. That will be 5 pi over 6 radian. Okay, so this is the answer for the question number 4b. Okay, so now we move on to the question number 5. So look at question number 5. We have a plane pi has the equations that given like this. This is the vector equations of plane. And we want to find the Cartesian equations of plane pi, giving the answer in terms of ax plus by plus cz equal to d. Okay, then okay, that is a part A. So first of all, we need to find the cross product between this vector and this vector. It will be 1, 0, 1 and a 2, 3, 0. So if we do the cross product, then you will get negative 3 I plus 2j plus the 3k. That will be your normal vector. So to find the Cartesian equations of plane, just take the normal vector. Normal vector is a negative 3, 2, 3. That is your random variable, random position vector, x, y, z. And you need to have a fixed point. So the fixed point will be, or the position vector will be a negative 2, 3, 3. So you get negative 3x plus the 2y plus the 3z is equal to the 9 plus 6 plus 9. 9 plus 6, sorry, this is a 6 plus 6 plus 9. So you will get this as a 21. So therefore, your Cartesian equations of plane will look like this. So this is the answer for part A. And for the part B, we need to look at this statement first. This is the line L passes through the point B with the position vector 2, negative 3, 5. And it's parallel to K. Okay, so we will bring this information to the part B. So we have a line L that passes the point B parallel to K. So P just now was the P was 2, negative 3, 5. 2, negative 3, 5. So we write like this. Okay. So we want to find the L meets pi. Okay. So that means we need to find the intersections between the line and the plane. So we just combine these two matrices, become one, call this one equation 1. And just now the pi was a negative 3x plus the 2y plus the 3z is equal to 21. I call this one equation 2. The r over here is actually represent the x, y, z. So you just say that you put 1 into 2, then you get negative 3 times 2 plus the 2 times negative 3 plus the 3 times 5 plus d is equal to 21. So if you solving them, expand them and solve for the value d, then you can get this as a negative 6 minus 6 plus 15 plus 3d is equal to 21. So you will get the d is 18 divided 3. 18 divided 3 is a 6. Okay. So therefore, your intersections position vector of the point L meets pi is equals to this 2, negative 3, 11. Okay, so this will be the answer for number 5B. And moving on, we have a 5C. We want to calculate the acute angle between L and pi. So we know that this is the L, this is the normal vector. Okay, so this is the L. So the acute angle between the line and plane is over here. So, but we need to use the dot product of n dot the p is equals to the magnitude n, magnitude p, cannot say p, magnitude a. Maybe I call it v, directional vector of the line. What we found is actually an alpha. What we found is actually the alpha over here. So to find the acute angle, we just put modulus. So we can just put it like this. Your normal vector is a negative 3, 2, 3. Then your v just now is a directional vector of a line is a 0, 0, 1. So this will be a 9 plus 4 plus 9. This will be a 0 plus 0 plus 1. So your cos alpha will be equals to 3 over the square root of 32. Okay, so you just go and find the angle. So your alpha will be 50.2 degree. So your alpha plus theta is equal to 90 degree. So therefore your theta is 39.8 degree. That will be the answer for number 5C. Now we move on for the question D. We want to find the perpendicular distance of a point P to the plane pi. So this one is quite easy. Okay, so we have a point P. P is a 2, negative 3, 5. 2, negative 3, 5. So we want to find the perpendicular distance. We have a formula for that. So the pi is given as a negative 3x plus 2y plus 3z is equal to 21. So we just need to make it become negative 3x plus 2y plus the 3z minus the 21 modulus divided by the square root of the negative 3 square plus 2 square plus 3 square. And the value inside here, the x, y, z, we will fill up the x, y, z over here. So we just need to put the 2, negative 3, and 5 And use a calculator to simplify it. You get 18 over square root of 22. Or you can give me the answer in decimal place, 3 significant figure. That will be your answer. Okay, so this will be the answer for question number 5D. And now move on. We have a question number 6. Number 6. We have the curve with the polar equations of r equal to the 2 cos theta multiplied by 1 plus sine theta. For the theta is between 0 to pi. 0 to pi over 2. Find the polar coordinates of the point on C that is the furthest from the pole. Furthest from the pole, that means we are looking for R max, the maximum R. So to find the maximum R, we just need to do the dr d theta. So we just need to keep the right, differentiate the left, go down rule, plus keep the right, differentiate the left. So your dr d theta equal to 0. That will give you 2 cos square theta minus the 2 sine theta minus the 2 sine square theta equal to 0. We have a quadratic trigonometry form over here. We can cancel all the 2, and I will make the cos theta become, cos square theta become 1 minus sine square. All the 2 cancel. All the 2 here can be cancelled. Then you will get this as a sine theta minus a sine square theta. So you'll get 2 sine square. And then plus 1. Plus sine theta minus 1. So let's see, can factorize it or not. I think yes, we can factorize it. Sine theta, 1, 1. So the sine theta is equal to half, and the sine theta is equal to negative 1. Your theta over here will be pi over 6. The theta over here will be a 3 pi over 2. This will be rejected because our theta is only in the first quadrant. Okay, so therefore your answer will be the theta equal to pi over 6. But we're looking for points. We cannot stop at here. So we need to continue. When the theta is equal to pi over 6, my r is equal to the 2 cos theta, 1 plus the sine theta. That will be a 3, 1 plus a half. Then you will get 3 sub 3 over 2. So therefore, your R max, your coordinate point will be R and theta. Okay, done. This will be the answer for the question number 6A. Move on. 6B, we want to sketch a graph. So to sketch a graph, nothing tricky. We just need to build a table. So our theta is from 0 to pi over 2. So we start from 0. Then it will pass through the 30 degree. It will pass through the 45 degree. Pass through the 60 degree. And lastly, it will pass through the pi over 2. So just use your calculator. Press the value because our R is equal to the 2 cos theta, 1 plus sine theta. So just use your calculator to multiply, to substitute them inside. So this one is the 2. This one is a 0. This one just now we know is a 3 sub 3 over 2, the R. But it's not useful over here when we want to plot the graph. So we need to convert them to decimal. If you convert them to decimal in 1 decimal place, you get 2.6. That will be 2.4. This one will be a 1.9. So just use your calculator to help you to get the answer will do. Okay. So right here, once you have all the values, so I just use a ruler and a protractor. Make sure that you can draw it nicely, 45 degree, but I draw it freehand. So my graph may not look very accurate. So this one is a 30 degree. And this one is a 60 degree. Two unit. So at first is this, and after that is this. Okay, so we have settled these two. Then in the middle, so just need to measure accordingly. So again, I draw in freehand. My graph may not look very accurate. Okay, so this one, it will be something like this. This one will be something like this. Something like this. So your graph, okay. Okay, so this will be your graph. Okay, so your graph will look like something like that. This is the answer for the question number 6B. Now move on. 6C, we want to find the area of the region bounded by the sea and the initial line. Okay, initial line. So that means we are looking for the whole area over here. We're looking for the whole area over here. Okay, so to find the area, just the formulas only. You need to know the formula. So the area will be half r squared d theta from 0 to pi over 2. So it's actually half r is 2 cos theta 1 plus the sine theta square d theta. So if you expand them, then you will get this one as a 2 cos square theta sine square theta plus 2 sine theta plus 1. Oh, so this is not easy because you expand them, you get a 3 different type of trigo to integrate. And these 3 different type of trigo need to use 3 different method to integrate. Okay. So for this one, we will use a double angle formula of sine 2 theta. Then you'll get this one as a half sine 2 theta square. Okay, you'll get half sine 2 theta square. This one, we just leave it. This one, we also use a double angle formula. You make it become 1 plus cos 2 theta over 2. So to save my space, I will write this one as the 1 over 4 sine square 2 theta. Okay. So continue. I will still continue to make it become 1 minus cos 4 theta. I apply again a double angle formula. The middle one still copy down. This one I expand them, split them, become 2. Okay, so this is what we have. Then I think we can multiply the 2 inside so that we can get 1 over 4 minus the 1 over 4 cos 4 theta plus the 4 cos square theta sine theta plus a half plus the half cos 2 theta d theta. So to save space, I will combine this and this together. 1 over 4 plus a half. 1 over 4 plus a half then you will get 3 over 8. Half cos 2 theta is over here. Okay, so I am combining this and this together. Oh, nearly forgot because I multiplied the 2 inside already. So this is not, if I multiply the 2 inside, this is 1 over 4. And then this one is 1 plus cos 2 theta. Okay, nearly forgot. So this one is the add together. Add together. So this it will be, if you add it together, then it will be 5 over 4. 5 over 4. Okay, 5 over 4. It's a mistake. So you will get 5 over 4. And this one you will get cos 2 theta d theta. Okay. So now we are ready to integrate. This one is easy. This one is easy. This one is easy. This one, we will use the formulas of f prime theta, f theta power n to integrate. Okay, so this, if you integrate them, you will get this as a f theta power n plus 1 over the n plus 1. Okay, so you can see that just now the one that we copied down, the formula, the form is already there, so we don't need to change anything. So now we are ready to integrate. You will get this one as a 5 over 4 theta minus a 1 over 16 sine 4 theta. This one will give you 4 over 3 cos cube theta, but you need to put a negative because differentiate cos, you're supposed to get a negative sign. So this one is a half sine 2 theta. This is a 0 until pi over 2. So this one have to be careful. This is a plus. After you integrate, got negative. Because you just need to think about in this way. If you differentiate negative 4 over 3 cos cube theta, then you will get positive 4 cos square theta sine theta. Okay. That will be easier to understand. So this one, if you substitute them inside, you will get 5 over 8 pi. This one is a sine 4 theta. It will be a 0. 0. Minus the 0, minus the 0, minus a 4 over 3, plus a 0. Okay, so at the end, you will get this one as a 5 pi over 8 plus the 4 over 3 unit square. Done. So this will be the answer for the question number 6C. And move on. We have question number 7. We have the curve C that has an equation like this. And first question, part A, we want to find the asymptotes of the C, all the asymptotes of the C. So to find the asymptote, we usually start from the horizontal asymptote, vertical asymptote, sorry. For the vertical asymptote, you just need to solve take the denominator out and then let it equal to 0. And then you can see that your x is a plus minus 1. And therefore, your vertical asymptote is x equal to 1 and x equal to negative 1. And as for your horizontal asymptote, you just need to find the limit of x approach to infinity of these expressions. So you can see that for this case, your numerator, the degree is smaller than the degree of the denominator. So eventually, when the x go to the infinity, you will get 0. That will be your horizontal asymptote. Done for the number 7A. So now we move on to the question B. We want to find the stationary point. So to find the stationary point, we just need to do the dy dx. Just have to differentiate it carefully. Keep the bottom, differentiate the top, minus keep the top, differentiate the bottom divided by the bottom square. So you can simplify them. Then you will get this one as the 16 plus 16x squared plus 40x divided by this. Plan to simplify it further because I just need to focus on the stationary point. Then to find stationary point, your dy dx must be 0. That means the 16x squared plus the 40x plus the 16, your numerator must equal to 0. All can divide by 8. Try to factorize it if we can. So we can factorize it. Then you can get x is a negative half and x is a negative 2. So this will be the x coordinate for the stationary point, but we are looking for point, so we need to find the y. So when the x is a negative half, just use your calculator. When the x is a negative 2, also just use your calculator. You press the calculator yourself, then you will get this one as a 1, this one as a 1 over 4. So therefore, stationary point it will be the negative half 1 and a negative 2 1 over 4. We just need to find the stationary point. There's no need for us to check which one is maximum, which one is minimum. Okay, we just later when we plot the graph, then we will roughly know that which one is maximum, which one is minimum. So now we move on to the C. It's time to sketch the graph. But before we sketch a graph, we need to find the coordinates of the intersections with the axis. That means intersect. When x is a 0, what is your y? So your y will be 5 over 4. Okay, so you will get this point. That is your intercept. We call this one the y-intercept. Then when your y is equal to 0, your 4x plus 5, your numerator will be a 0. Then your x will be a negative 5 over 4. That will give you the x-intercept. Okay, so these are the things that we need. Now we just need to put all the information that we have into the diagram over here. So I draw with freehand. So my graph will not be perfect compared to those using graphic calculator to draw. Okay, so over here I just show you the graph. Okay, but again, I am not using freehand. In exam, you're supposed to use a ruler with a proper scale to sketch a graph. So this is a negative 2. Negative 2 because we have a point called the negative 2 1 over 4 and negative half 1. Okay, 1 is over here. Negative half is over here. Then negative, this one is a quarter, 1 over 4. Okay, so we know that one of them must be maximum, one of them must be minimum. Then intercept 0, 5 over 4. 0, 5 over 4, 5 over 4 is somewhere here. Then negative 5 over 4. Negative 5 over 4 is somewhere here. So you can see that your graph will pass through this point. So we know that this is going to be our maximum. This is going to be our minimum. And we still have something else over here. Okay, So this will be your graph for the number C, number 7C. Done. So we just write down y is equal to the 4x plus 5 over the 4 minus the 4x squared. So now we move on for the question D. So D, they want you to sketch a graph of y equal to the modulus x, y equal to the modulus of the functions. So, okay, let us sketch. Modulus means you just have a reflection. That means the negative side all will be reflect, goes up. So I need to redraw again. So the graph have to be repeated again, but this time we can make it faster. -1. This is the x, this is the y, this is the 1 over 4, this is a 1, this is a 5 over 4, this is a -half. Your graph will pass through to show the features. Then this is a -5 over 4. That is a -2. Reflect, goes up. This one goes up like this. Okay, so this will be the graph for y equal to the modulus of 4x plus 5 over the 4 minus the 4x squared. Okay, then we are looking for the solutions for this one. So for these solutions, we can actually write down first. Then we make it become modulus of a 4x plus 5 over the 4 minus a 4x squared greater than 5 over 4. Okay. So that means we are looking for 5 over 4 over here. We draw it. Okay, at this side. So we have a 4 intersection point. So our job over here is to look for this 4 intersection point. So to find the 4 intersection point, we need to let them be equal first. Take away the modulus. We let them be equal. This one is positive. Another one will be negative. So solve it carefully. You will have 16x plus 20 is equal to the 20 minus the 20x squared. Over here, you will get 16x plus 20 equal to the -20 plus the 20x squared. So over here, you will get this as a 20x squared plus 16x equal to 0. Factorize the 4x out, you will get 5x plus 4. So your x is a 0, your x is a -4 over 5. Then this one, it will be the 20x squared minus the 16x minus the 40 equal to 0. Divide everyone by 8, 4. 5x squared minus the 4x minus the 10. So you just need to use the quadratic formula. -b plus minus of the b squared minus the 4ac divided by 2a. Then you will get 2 plus minus of 3 sub 6 over 5. Okay. So you get four values. So if you list them out, you can see that actually 2 minus the 3 sub 6 over 5 is actually less than the is actually less than negative 4 over 5. And this one is less than 0. And this one is less than 2 plus 3 sub 6 over 5. You can see the sequence if you arrange them in the ascending order. Okay, so which means if you draw the lines over here, this intersection point, it will represent the x equal to the negative. It will represent that x is a 2 minus a 3 sub 6 over 5. This will represent negative 5 over 4. This will represent 0. And this will represent 2 plus 3 is 6 over 5. So from here, you can actually see that the answer, just say that from the graph, your answer will be here. Like this and like this. Okay, done. This will be your answer for the question number 7, number 7D. And this will be the last question for this paper. Okay. So I'll stop the video here. I'll see you next time, and bye-bye.